Class 9 champions, Class 9th ninjas. Welcome everyone on your favorite channel Deeksha Vedantu CBSE English, and this is your Sonu Sir. My dear champion, I have come up with part 2 one-shot video of the world of numbers. My dear lovely students, the student who is new and who is watching the videos, the student who have come on this channel for the first time, part 1 of this chapter, the part 1 of one shot video of this chapter has already been uploaded on the channel. Go, if you haven't watched the video yet, go and watch the video. In that video, I have already discussed everything. Almost 80% of the world of numbers I had finished in that particular video. So my dear champion, for the clarity, for concept, to understand the basics about numbers, how the numbers were invented, what is natural number, whole number, rational, irrational number, what is how many types of decimal expansions are there. So I have taught you everything in that video. Go and please ensure to watch that video first before watching this second. But few topics were left, so we are going to discuss all the topics that were left in that particular video, part 1. So in this video we are going to discuss everything. How to represent the rational number on number line, how to represent irrational number on number line, how we can calculate the number of so many rational numbers between two rational numbers. So we are going to talk about everything here in this video. So let's start. Okay, so the first topic here is rational on the number line. Means we are going to talk about here how to represent the rational numbers on number line. Very easy topic. Please focus on screen. Watch the video with very complete concentration, with good focus. Then only you will be able to understand. Okay. So let's talk about how to represent the rational numbers on number line. Okay. So you all know, my dear champion, every rational numbers marks exactly 1 point on the number line. Let me give you the clarity of the first line. First line says that if we draw a number line, this is 0 here, and the right side of the 0 are positive. 1, 2, 3, and left side of 0, all numbers are negative. -1, -2, -3, and minus infinity till infinity. 1, 2, 3, and so on till infinity. Positive infinity, negative infinity. My dear champion, the first point says that every rational number marks exactly 1 point on the number line. Yes, my dear champion. For example, if I ask you, represent 4 on the number line, 4 means what? 4 by 1. So what will be the representation of 4 by 1? 4 by 1 will be here, somehow here. This will be 4 by 1, means 4. If I ask you, represent the number 4 by 8. Now you might get confused. It may be confusing for you. 4 by 8, sir. What does it mean by 4 by 8? Champion, 4 by 8 means what? 1 by 2. And 1 by 2 is what? 0.5. So we can represent 0.5 on number line. 0.5 is the midpoint of 0 and 1. So this will be the 0.5. I hope this is clear to you. So the first point says that every rational number marks exactly 1 point. This is the 1 point. This is the 1 point. For 3, this will be the 1 point. This will be the 2.5, right? So exactly 1 point on the number line. Moving ahead. To plot P by Q, divide the unit gap between two integers. I'll be teaching you this on the next slide. This second part is very important. Third point, negative rationals sit to the left of 0. I have already told you, all the values negative comes left side of the 0, and all the values positive comes right side of the 0. Okay, and this is the mirroring the position ones. Very good. One question is here, so we will be doing this question, but later on. First, understand, my dear champion, how to represent the number line, a rational number on number line. Let me give you a very magical method. So the topic is representation of rational numbers on number line. Very interesting topic. Okay, representation of rational numbers on number line. My dear champion, there are two situations. There are two situations of rational number. The first case will be when the numbers are whole number. Numbers are whole number. I hope you know whole number. whole number means the number such that 1, 2, I mean only 7, 11, I mean such number. Only one digit is there. There is nothing in the denominator. Only a single number is there. Such numbers are called whole number. So if I ask you to represent whole number on number line, this is very easy. Draw a number line. This will be 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. This is 1, 2, 3, 4, 5. This will be minus 1, minus 2, minus 3, minus 4, minus 5. Now I have asked you to represent these numbers on number line. Very easy. So now we can represent 1. This is 1. Now 2. This is 2 here. Now 7. 7 will be here somehow. 6 and this will be 7. So this is 7 here. Now 11. 11 will be here. 8, 9, 10, 11. 8, 9, 10, 11. So this will be 11. Now 5. Where will be 5? 5 is here. So representation of whole number type of rational number is very easy. We can directly represent at selecting one point of that particular number according to the position. Very easy. But the questions comes up. The most confusing thing, second case. Second case students, I mean second case scares students, most of the student. And what is second case? Second case is, my dear champion, when the numbers, I'm talking about your rational number. Please keep it in mind because we are talking about rational number. But when the rational numbers are in the form of whole number, this is very easy to represent. But if the rational numbers is in fraction form, wow, is in fraction form, then how to represent? This is the important topic. This is very important. Let me underline this. This is very important. Trust me, my dear, this is very important. If the rational number is in fractional form, then how to represent the rational number on number line? This is very important. So let's do a question. Let's understand by question. So I'm giving here question here. Question, let me use another color. Okay, let's do a question here. Represent 7 by 4 on the number line. Wow. Represent 7 by 4 on the number line. Please understand, everyone. Representation of whole number is very easy because all the numbers on number line is in whole number form. So we can directly represent by selecting the point according to the number. Right? This is important. How to represent fractional value on the number line. So my dear champion, to represent fractional rational number on number line, I am going to give you very powerful magical method. And method says that the first condition is what? Come on. Look at first step is look at the denominator. Come on. Please try to understand what I want to say. Look at the denominator. Okay. So in this fraction, denominator is 4. Let me write here. Look at the denominator. So I am writing here for according to this question, which is 4. So first step is what? Look at the denominator always. I hope you are getting my point. Now the second step will be divide each unit. Each unit means what? The gapping between each number is called each unit. These are the each units. The gap between 6, 7, the gap between 0, 1, the gap between 1, 2, the gap between 2, 3. This is called each unit. Because the gap is 1 unit, 1 unit, 1 unit. So divide each unit in how many parts? Yeah, according to this. Denominator decides how many parts will be there in each unit. So divide each unit in how many parts, champions? 4 equal parts. Yes, my dear champion. So how many parts will be there in between each unit? Denominator decides. Have patience, have patience. Let's reach to the final answer. Don't worry. Third, after doing this, looking at the denominator, making the number line in such a way that each unit is having 4 equal parts. Now start counting start counting from 0. Come on, from 0 and till what? According to numerator. So how many countings you have to do? According to numerator. Numerator is 7, so you have to move 7 units, 7 parts from 0. And if the number is positive, so move positive direction. So start counting from 0 according to what, champions? Numerator. Yes, according to numerator. Let me show you the result here. So okay, let me use another color for number line. So I'm using here, champion, the red color. So this is number line. Very good. I can use your straight line from this. So we have number line here. This is number line. Okay, now my dear champion, look at 0. This is 0 here. This will be the 0. This will be the 0. Now look, what is the first point? Look at the denominator. Denominator is 4. And what we have to do with the denominator? We have to divide each unit in 4 equal parts, because denominator is 4. So 1, 2, 3, 4. 1, 2, 3, 4, and this will be your 1. This will be your 1. So 0, 1. 1 unit is divided into 4 equal parts. Again 1, 2, 3, and this will be 2. So each unit will be divided into 4 parts. Again 1, 2, 3. How many parts? 1, 2, 3, and this will be your 3. Wow. Similarly 1, 2, 3, and this will be your 4. And similarly at the left side of 0, same procedure will be this. This will be minus 1. 1, 2, 3, 4. This will be minus 2. So this is all about. Now moving ahead. Now what is the third point, everyone? Please focus on third point. What is third point? Start counting from 0. Start counting from 0 according to numerator. So numerator is here 7. So let's start counting here. This is 0. So 1, 2, 3, 4, 5, 6, 7. This is the answer that we require. This will be your 7 by 4. This is the answer. 7 by 4. This is the 7 by 4. Let me prove you how. My dear champion, after 7 by 4, this will be 8 by 4. And 8 by 4 is equal to 2. And this is equal to 8. 2. Wow. Now, one more thing. This is, my dear, 1 by 4. This is 1 by 4, 2 by 4, 3 by 4, 4 by 4, 4 by 4, 4 by. This is equal to 4 by 4, and which is equal to 1, which is absolutely correct. Wow. So my dear champion, let me show you clearly here by using blue color. So my dear champion, after 0, this first point, this first line is indicating 1 by 4. This second line, this second point is indicating 2 by 4. This third point is indicating 3 by 4. And the fourth will be 4 by 4, which is equal to 1. Similarly, if we move ahead, this 4 by 4, now 5 by 4. Now this will be 6 by 4, and this is already 7 by 4. That was the question. And this is what? 8 by 4, which is equal to 1. Now this will be 9 by 4. This will be 10 by 4. And this will be 11 by 4. And can you see here? This will be 12 by 4. And 12 by 4 is equal to 3. Wow. This is all about. And if you move ahead, 12 by 4, 13 by 4, 14 by 4, 15 by 4, 16 by 4. This will be 16 by 4. And 16 by 4 is equal to 4. And this is absolutely 4. This is the beauty, how to represent the fractional value on the number line. I hope you have understood what you need to do. My dear champion, always follow this. First, whenever fraction is in front of you and you have to represent the fraction on number line, what should be the first step? Always focus on denominator. Denominator will give you how each unit will be divided. How each unit will be divided. If denominator is 4, it implies that the gap between 0 to 1 will be divided into 4 parts. The gap between 1 and 2 will be divided into 4 parts. The gap between 2 and 3 will be divided into 4 parts. So number of parts, how many parts will be there, that decides denominator. I hope this is clear to you everyone. And numerator decides the position, the counting, how many steps you have to take. How many steps you need to take from 0. Make sure from 0. So 7 decides. So my dear, let me write here. Numerator decides position from 0. Okay. And this decides number of parts. Number of parts in each unit. Right? This is very important, champions. This is very important point. Okay, moving ahead. So my dear champion, now do this question. Minus 5 by 4. Minus 5 by 4 can be written as minus 1.25. 2 by 3 is equal to 0.67 and this is positive. 3 by 2 is equal to 1.5. This is positive. If you draw the number line, this will be 0, 1, 2, 3, 4. You all know, as you move this side from 0 left to right side, so a number increases because the positive values are increasing. But as you move this side from right to left, from right to left, all the values are negative, and negative values are with greater mathematical value. It means that when you move right to left, the number is slightly decreases, so the numbers decreases. Now if you plot minus 1.25, so minus 1.25 will come here, somewhere here. This will be the minus 1.25. If you plot 2 by 3, 0.67, so 0.67 will be here. This will be, let me use another color. So yeah, this will be, this point is of course minus 1.25, right? Minus 1.25. Now this will be, this point will be of 0. No, this will be somewhere here. This here. Okay, slightly beyond to 5, so this will be 0.67. Right, now moving ahead, 3 by 2 is 1.5. 1.5 will be between 1 and 2, so this will be 1.5. Exactly the center of 1 and 2, so this will be 1.5. So can you see here which will be greater? This is greater because this is at right side. Okay, and this is the left side. The first value is the left side. The most left side is 1.25. So this is the lowest one. And which is the greatest one? This will be the greatest one. 1.5. So 1.5 is 3 by 2. So 3 by 2 is greater. Then this is 0.67 and 0.67 is 2 by 3. Then 2 by 3 will come. And then last will come as minus 5 by 4. So my dear champion, the number at the right side is greater and the number left side will be smaller, and when you are moving left, more left, the number will be decreasing slightly, and as you are moving to the right side, the number will be decreasing. This is the beauty. Greater number this side, as you are moving in this direction, the numbers will be increasing, the power of the numbers will be increasing, but as you are moving here left side, the power of number will be decreasing. If I ask you in minus 4 and minus 2, which is greater? Minus 2 is greater because minus 4 is the left side of minus 2. Minus 4 is smaller than minus 2 because minus 2 is the right side and minus 4 has become left side. So right side greater value, left side smaller value. Please keep it in mind. Please keep it in mind. Let me give you here. Right side greater number, okay, and left side everyone smaller number. So my dear, you can compare any fractional number. If you are comparing two fractional number, two rational number, so the right side, the number which is right side to the another number will be greater and the number which is at the left side will be smaller. So please keep this in mind. Moving ahead. Okay, so this is done. I hope this is clear to you all, and this is the logic how to draw the fractional rational number or number line. Whole number representation on number line is very easy, but this is the most important thing, how to represent rational number, I mean fractional form rational number or number line. Moving ahead. Okay. Now moving ahead, density of rational numbers. What does it mean by density, champion? Density means counting number of rational numbers. Density, I can say simple. We are talking about here number of what? Rational numbers between two rational numbers. If two rational numbers are there, how many rational numbers will be there in between two rational numbers? So this is the topic here. So my dear champion, let me give you the theoretical clarity. Between any two different rational numbers, there are infinite many rational numbers. Yes, my dear. You can find infinitely many rational number between, whether the numbers are continue, doesn't matter. If the 2 and 3, we can write 2 by 1, 3 by 1, so both are rational numbers. So if the numbers are consecutive, even between two consecutive numbers, there will be infinite rational number. How to calculate? If you find out first rational number, so let's find out the average of this. So 2 plus 3 divided by 2, this will be 5 by 2, which is equal to 2.5. Oh my God. First rational number is ready. Oh my God. 2.5 can be written as 25 by 10. So this is 5 by 20. This is 2. So this is equal to what? 5 by 2. So 5 by 2 is the first rational number. Let's assume this is 5 by 2, which is equal to basically 2.5. And 2.5 is the will come between 2 and 3. Now, if you find out the average, I mean same process by doing this. Now average between 2 and 5 by 2, again the new number will come. If you find out the average between 3 and 5 by 2, again the new number will come. If you find out whatever the number has come here, now if you find out the average between this and this, again the new number will come. So it will move on. It will go on. There is no any end. So that is the reason why I'm telling you guys, between two rational numbers, there are infinitely many rational numbers are possible. Moving ahead. Because of this, the rational numbers densely packed. I have already told you, na, between two consecutive numbers, between 2 and 3, we are getting so many rational numbers. Between 2 and 3, so many rational numbers will be there. So many rational numbers will be there. So look at the crowdness. Oh my God. Look at the crowdness. Huge crowd is there, and that is why we are calling here densely packed. So between two rational numbers, there will be so many rational numbers, infinite rational numbers. Okay, how to find? One numbers between A and B is always the average. I have already given you the value. 2 plus 3, 5, 5 by 2. 5 by 2 will be present in between 2 and 3, and that is also a rational number. So if you have A and B two rational numbers, so you can calculate average of A and B, that will be giving you the new rational number. So no rational numbers has a definite next rational number after it. Find a rational number. Let's do a question based on this theory. Let's do a question here. I hope this is clear to you all. So how many rational numbers are present between two rational number, champions? Infinite rational numbers. Let's solve this question. Okay, the question is, find a rational number between 1 by 4 and 2 by 1 by 2. Okay, so we have 1 by 4 here and we have 1 by 2 here, right? And we have to find out one rational number between these two. Oh my God, come on, find out the average. Let's find out the average of both. So 1 by 4 plus 1 by 2. 1 by 4 plus 1 by 2. Divided by 2. This is the way how to calculate the average. 1 by 4 plus 1 by 2 divided by 2. Let's solve this. So on taking LCM of these two fractions, 4 will come. 4 1 ja 4, 1 will come. 2 2 ja 4. 2 2 ja 4, 2 will come. And this 2 will be multiplied with this 2. So 2 plus 1, 3 divided by 8. This is the rational number which will be present between this and this. You can verify if you calculate the decimal of this value. So I think 0.25 will come. If you find out the decimal of this value, this is 0.5. 0.25, 0.5. So this number will be between 0.25 and 0.5. You can verify this. So 3 by 8 is the answer. Now, one more thing. Then one more between that and 1 by 2. Okay. Now the question is asking. Question, I hope you have understood. The question was asking to find out the rational number between this and this first. And one more question is, after getting 3 by 8, what will be the decimal value of 3 by 8? Let's verify. Let's divide 8 by 3. So this will be 0.0 and 8 3 is 24. 8 3 is 24. What is the number here? 2 plus 1. 4 by 4, 4, 4. This is 4 1 4, 2 2 4, this is 3, 3 by 8. Yeah, perfect. 1 by, okay, let's divide 3 will be divided by 8. Okay, so 8 3 are 24, 24, and this is 0 8 7. So we are getting 0.37. Perfect. Now look at champions. What is 1 by 4? If you calculate the value of 1 by 4, 1 by 4 means divide 4, divide 1 will be divided by 4. So 0.0, let's divide this. So 4 will be divided by 1. 1 will be divided by 4. So 0.0. Now 4 1 ja 4. 4 2 ja 8. Now 2 0. I have already told you 0.25. So decimal expansion of this fraction is 0.25. Right. Decimal expansion of this 1 by 2 is 0.5. And can you check here? The decimal expansion of 3 by 8 is 0.37. Wow. It indicates that our answer is absolutely correct, because 0.37 will lie between 0.25 and 0.5, which is absolutely correct. Right. So we have verified. Now moving ahead. Here in this question, we have to find one more rational number between that, between that we were calculating in the first part of this question. So second part is 3 by 8 and 1 by 2. We have to find out one more rational number between the new rational number that we got here and 1 by 2. So what we need to do? Again, average. So let's find out average. To find the rational number, we can calculate the average value. So let's add 3 by 8, 1 by 2. So let's do one thing. Let's add, if anyone of you is getting confused, sir, how you did calculation here. So let's do the calculation of addition of these two fractions first. So let's add. What will be the fraction? LCM will be 8. 8 1 ja 8, 3 will come here, 2 4 ja 8, 4 will go there. So this is 7 by 8, right? But we want average, so we have to divide by 2. So average will be equal to, so 7 by 8 divided by 2. So we all know this is a fraction and this is also a fraction. 2 can be written as 2 by 1. So when two fractions are in division form, so always multiply top value from the lowest value and the middle value will get multiplied. So 7 1 ja 7 and 8 2 ja 16. This will be the answer. 7 by 16 is the one more rational number between 3 by 8 and 1 by 2. So what we are doing here? We are just calculating the average value. So you can find out infinite many rational number between two rational number by calculating the average value of given rational number. And average value, we all know, sum of observation divided by number of observation. Moving ahead. Okay. Now the most important question, most important for your exam. This is the topic. Okay. Numbers beyond fraction. My dear champion, number beyond fraction means what? Numbers except fraction. Numbers except rational number. So there are few numbers when the numbers comes in under root form, under root 7, under root 5, under root 3, or 2 under root 3, such kind of numbers. So these are apart from beyond fraction, beyond rational numbers. So such numbers are called irrational number. Why we are calling this as irrational number, champions? Because when you calculate the under root value of 7, the decimal expansion will be non-repeating, non-terminating and non-repeating decimals. When you calculate the root 5 value, let me show you root 5. Do you know the value of root 5? I hope you should know the value of root 5. Root 5 is equal to 2.23606 and so many. The number after decimal is repeating in unsystematic order. Sometimes 6 comes up, sometimes 0, sometimes, the repetition is not perfect. The repetition is not in rhythm. So this is called, such repetition is called non-terminating and non-repeating decimal. And if the situation is non-terminating, non-repeating, if this is non-terminating, non-terminating, non-repeating, because here is repetition is not perfect. Okay. So if the decimal expansion is non-terminating, non-repeating, so we can't write this decimal in the form of p by q. So this is not rational number. And if this is not rational number, this will be irrational number. This will be irrational number. I hope this is clear to you all. Let me switch on the AC. It's a little bit hot inside. Okay, this is clear to you all. So number beyond fractions are irrational numbers such as √2, √3, √5, pi also. When you write the decimal expansion of pi, you will get amazed to see the result. The decimal expansion of pi is very unsystematic. Very unsystematic. If I write here pi 3.141592, and look at after decimal the numbers are not repeating in perfect way. 3.14159. Look at the repetition. Repetition is very unsystematic. So if the repetition is unsystematic, we can't write in the form of p by q. And if we can't write in the form of p by q, it means this is not rational. And if this is not rational, it has to be irrational number. I hope this is clear to you all. Clear, champions? So we are going to talk about, so their decimal expansion never ends. So that is why we are calling this as non-terminating. So never ends. Never ends means this will be non-terminating. That is why this is called what, my dear champion? Non-terminating, because of this. And never settles into a repeating, and this is why this is called non-repeating, or we can also say non-recurring, because after decimal the numbers, after decimals the number which is appearing here is not in systematic order. Sometime 1 is coming, sometime 4, then again 1, then 5, then 9, then 2. Okay, so this is called non-terminating, non-recurring. You can also say non-repeating. So such numbers are called irrational numbers. So can √2 be written as p by q? No, not at all. No, √2 is irrational number. The proof is on the next slide. So let's do the proof, how we can prove √5, √3, √7 except perfect square. √4 will become a rational number because √4 will give you 2. And 2 can be written as 2 by 1. √16 is also rational number because √16 will be 4. 4 by 1 is a rational number because 16 is a perfect square. Similarly, √49 means 7, or 7 can be written as 7 by 1, which is a format of rational number. So except perfect square, all the remaining numbers are irrational. Okay, please keep it in mind. So let's do question here. This is very important, champion. How to prove irrational number. So we are going to prove irrational number, and the proof method is called contradiction method. Can you see here? By contradiction method. This is very important. Okay. So my dear champion, to prove √2 is irrational, we start solving this question after assuming √2 as a rational number. So when you are proving √2, √3, √5, √7, √6 irrational number, first assume that the given value is rational number. So let's assume what? √2 is a rational number. Yes, my dear champion. Some student might be getting confused, sir, why this is called contradiction method. So let's just wait a little while, everything will be clear. What does it mean by contradiction? Contradiction means some error occurs. Some error has appeared. Our assumption and the result is not matching. According to assumption, the result is not appropriate. Such situation is called contradiction. So let's solve this question. So to prove √2 as irrational, we have to assume is as a rational number. And once you have assumed √2 as a rational number, champion, we can write √2 is equal to p by q, because we have assumed here √2 as a rational number. My dear champion, one important information that you should not miss here to write, please. Here p and q are co-prime numbers. P and q are what kind of numbers? Co-prime numbers. And I hope we all know co-prime numbers. Co-prime numbers are such numbers, such pairs whose HCF is 1. I mean the pairs which are having common factor only as 1. For example, 3 and 11. If I ask you, is there any number which can divide both the numbers 3 and 11? There is no any other number except 1. So my dear, for this number, the greatest common divisor, I can say HCF only as 1. For example, 17 and 9. Tell me, is there any common factor of both the numbers? Only one common factor for the both numbers is HCF, which is 1. 1 can divide 17, 1 can divide 9. For example, we have so many examples. 11, 5, again, HCF will be 1. For example, 23, 3, come on champions, HCF will be 1. So such pairs are called co-prime pairs because the common factor is only 1. So here also we have assumed P and Q are co-prime pairs, and co-prime pairs means what? P can be divided by only 1 and Q can also be divided by only 1. There is only one common factor which is 1, and that is why we have mentioned here P and Q are co-prime. This mentioning is very important. Very important. Okay, moving ahead. Let me erase this co-prime pairs. Okay, so my dear champion, look at the solution. So here, if root 2 is written as P by Q, because we have assumed root 2 as a rational number, so root 2 can be written as P by Q. Now can we please cross multiply? So if we cross multiply, root 2 into Q will be equal to P. Root 2 into Q will be multiplied with P 2 and P will be alone. Now squaring both sides. If squaring both sides, what will be the scenario? If we square this side and this side, root will remove, so it can be written as 2q square, and this is equal to p square. And what does it mean by this, champion? 2q square is equal to p square. It implies that if 2 is in multiplication with q, and if we shift this to right side, if we pull this to right side, it implies that p square will be divided by 2. Because 2 is in multiplication with q. If 2 is in multiplication with q, it means when this 2 will go there another side, so it will be dividing p. So it implies that p square is divided by 2. So we can write p will also be divided by 2. P is divided by 2. Oh my God! What was our assumption? P and Q are co-prime numbers. But what we are getting? One more factor. Co-prime means what? Only one factor will be there. HCF is only 1. Means P can be divided by 1 and Q can be divided by 1. But what we got here? P is divided by 2. One more factor has produced. Okay. Now. So my dear, if P is divided by 2, P can be divided by 2. So we can write this information. Please ignore these things just for a while. Please forget these things just for a while. If I ask you, x can be divided by 3. Come on. X can be divided by 3. So we can write x is equal to 3y. 3 with any number. If x is divided by 3, so we can write x is equal to 3 with anything, any new variable, right? Because if 3 is here multiplication form, it implies that x is divided by 3. So here same thing. If p is divided by 2, so we can write this information p is equal to 2c. I am taking one more variable c. Because p is divided by 2, so t2 will remain in multiplication form with any new variable. I hope this is clear to you. And this is the most confusing point where, I felt a lot of students get confused here. Sir, how you are writing this? My dear, just focus on this line. If p is divided by 2, so p can be written as p is equal to 2 and one more new variable. Anything you can write at the place of c, y, k, m, t, whatever you want to write, you can. So this was the equation number 1. And this is equation number 2. Now please focus. Putting 2, if we put 2 in first, what will be the scenario? Now at the place of 2 we can put c. So this is p here. So 2q square, and at the place of p 2c will come. 2c whole square. Now solve this. So this is 2q square and 2c square will become 4c square. Oh my God. 2q square is equal to 4c square. Now this 2 will come this side, or we can also shift that 4 there. So we can write 2q square and 4 will come in denominator, and this is equal to c square. Can we please cancel this? 2 to 4. Now can you see here? Now q square is divided by 2. There p is divided by 2. P square is divided by 2. Then p is divided by 2. Here q is divided by 2. Oh my God. This is contradiction. Why contradiction? Because now our assumption has become wrong. Our assumption was P and Q are co-prime numbers. And P and Q are co-prime numbers means the common factor will be only 1. But here we are getting one more common factor in the form of 2. P is divided by 2. Q is also divided by 2. Hence, one more factor is 2. Which is violating our assumption. This is called contradiction. Contradiction. Now, our assumption and the result are not synchronizing. Our assumption and the results are not matching well. So this is called contradiction. Now the contradiction occurs. So we can write here Q square is divided by 2. So Q is also divided by 2 and this is contradicting. This is contradicting our assumption. What was our assumption? Our assumption was P and Q are co-prime. So only one factor is there, 1. But we are getting one more factor in the form of 2. So this is contradicting our assumption as this is contradicting our assumption as 2 is one more factor, but we assumed that P and Q are co-prime. So if this is contradicting, and why this is contradicting? Because our assumption was rational number. So root 2 is an irrational number. Root 2 can't be rational number. So root 2 has to be irrational number because the result is contradicting our assumption. This is the proof, my dear champion, and this is, most important question of your chapter, the world of real numbers. Very, very important. This question will definitely appear in your exam, whether it is formative assessment or your half-yearly examination. So thank you so much for watching, everyone. Moving ahead. Okay, the next is 3.7, the real number line. Very good. Wow. So my dear champion, listen. The real number lines means what? Come on, yaar. What is called real number? The combination of all rational number plus irrational number. The combination of rational and irrational number called real numbers. Yes, my dear. In real number category, irrational also comes. In real number, rational also comes. Yes, so we are going to represent, so we have already understood how to represent rational number or number line. Now we have to represent irrational number or number line. How we can represent irrational number also. So real number, what is called real number? R for all rational numbers together with all irrational number. Can you see here? The combination of rational and irrational called real number. Every real number is exactly 1 point on the line and every point is exactly one real number. This is absolutely correct. But even root 2 has its own point. Root 2 has also one point. If you go and if you find out the value of root 2 will be 1.41. And we know 1.41 will be something between 1 and 2. Yes, you can see here, this is root 2, 1.41. So my dear champion, rational number can also be represented on number line and irrational number can also be represented on number line. This is very important thing you should understand, champion. Is it clear to you? And I have already given you root 2 is equal to 1.41. And if you have calculated the decimal value of root 2, now you can you can represent the number exactly. But how to represent the root 2 directly on the number line before getting the decimal value? Is it any method by which we can directly represent the root function on number line before getting the decimal value? Otherwise, we can draw any irrational number after getting its value on number line. For example, root 5. Now draw root 5 on number line. We know root 5 is equal to 2.23. Now you can show the 2.23 will come slightly here. This will be the root 5. Are you getting my point? But without finding the decimal value, is there any method by which we can represent the irrational number on number line? So the answer is yes, there is some method. So let's do, how can root 2 be located on number line? So let me show you how to prove, champions. So to draw the irrational number on number line, let's do one example. Let's draw root 2 on number line. So root 2 on number line. Everyone, please understand this question. How to represent root function on number line. Okay, so to represent the root 2 on number line, draw the line here. First draw the line. Let me use another color. Draw a line. Okay, and this is, we all know this is 0 and this is 1. This is 1 unit. This is already 1 unit. Now draw a perpendicular at 1 equal to 1 unit. This, it should also be 1 unit. It was already 1 unit. Now draw a perpendicular. This is, let's say this is O. This is O and this point is A. Now draw AB, perpendicular line, exactly perpendicular, and which is also 1 unit. It was of 1 unit. And this is also 1 unit. Now if you apply Pythagoras theorem, so this OB will become root 2. This OB will become root 2. Wow. And if you want root 3, now again draw one more line here of 1 unit at 90 degree. So this will become hypotenuse. So hypotenuse will become root 3. Now root 4, similarly this will go in this format. But we want only root 2, so we'll stop till here at B. Now my dear champion, after getting root 2, now take compass and pencil and put the needle of compass at this point, and pencil at B point, and take the arc, draw the arc, taking OB as a radius. Draw the arc after getting the value of root 2. Now considering OB as a radius, and O as center, draw an arc here this way. So your arc will come here somehow, and this will be the value. This will represent the position of root 2, and root 2 is also equal to 1.41. So after 1, this result will come. I hope this is clear to you all. 1 unit, base perpendicular, so hypotenuse will become root 2. And now draw an arc. This point will represent the position of root 2 on the number line. Similarly, if you want root 3, now draw one more base, or you can say perpendicular of 1 unit. Now this will be hypotenuse. Now taking this as radius, draw an arc. So this will come here. So this will become root 3. And similarly, it goes on. I hope this is clear to you all. So this is the way how we can represent irrational number on number line. If you are having any kind of confusion in any particular concept, any point in this chapter, do let me know in comment section. I will making the particular separate video for that particular concept. If you are stucking somewhere in the any concept to understand the concept, so I can record special particular single video for that particular concept. So do let me know in comment section. Stay blessed everyone. Thank you so much for watching, and the student who have not watched the first part of this one shot video, the world of real numbers, go and watch the first video, part 1 also. Thank you so much. Stay blessed everyone.